Hello, everyone. Let me get off of crocodile hunting behavior, which I was reading, and let us go to Scratch. Now, Scratch is something you might have some experience with in previous years, elementary or middle school. Some people think it's for children, but I can assure you that it is truly not. If you don't already have an account, we can go to Join Scratch, come up with a username. I could just put Mr. Eastburn here, I guess. And just to be aware, the platform here for Scratch is used in a lot of computer science classes in colleges. And it's also taught at Princeton High School. There was a Scratch club. So don't think that this is in any way a baby activity or a child's activity, because this is fairly sophisticated in terms of what you might be able to do. And you can do it fast, which is the most important part. So I have my name, looks like I need to get rid of my period in the period of my name. Password is the date, whatever, it doesn't matter. No one's really going to hack into my account. Now you do have to enter in some demographic information. I guess everyone will see how long ago I was born, which seems longer and longer every year. You can choose to answer these sorts of questions, but you certainly don't have to. They're just collecting data on people in general who are using Scratch. To confirm your email, you will have to do that in order to share your project, which I am going to want to see your projects when we are complete. This will be another 100-point assignment. I'm going to lead you through it, though, so it's really not... Following my instructions is really all you have to do in order to get your good grade. You're confirming your Scratch account. For some reason, that button wasn't working, so I'll use the link instead. The URL takes me to the site, and now I am logged in, and I'm confirmed my email, and I'm going to go to create. This is where we make things happen in Scratch. You can code, you can draw, you can do all sorts of things. That's Scratch the Cat. First thing I'm going to do is get rid of Scratch the Cat. They used to have scissors at the beginning, at the top of the page. This is a newer version of Scratch that we're using right now. It's 3.0. I started way back in 1.0 quite a while ago. So we get rid of the cat, hitting the trash can. Now we're going to need to find a new sprite. That's what things that move on our page are called. We're going to make a replication of that Pleistocene park, the Ice Age park, where Sergei Zimov works with his son in order to recreate a habitat like the one that was seen in Siberia up to about 10,000 years ago when humans wiped out most of the large herbivores, which were helping to keep the planet cooler. If you can gain nothing else from my class, I would like you to think about ways to keep our planet cooler. I'm going to choose the zebra here because in terms of its body, it looks more like that horse that we would see in that Pleistocene park. Of course, zebras have stripes and horse generally do not have stripes. I will have to get rid of the stripes. So I hit my eyedropper, I pick a color, and I will go over to the fill, wait, how do I get there? Oh, no. All right, this is a little bit different than what I'm used to also, but I do have the paint bucket, which I can use to start filling in these stripes. Oh, except that the color defaulted to purple. I don't want purple. I want to go back to that same color I had before. So if I'm going to go to fill, I'm going to hit the eyedropper, and I'm just going to get rid of the stripes on my zebra to turn it into a horse. After all, horses and zebras are very closely related. I will get rid of the stripes. And while I'm doing this, again, I'll explain that Scratch is a language. If you look and you look up some of the projects on here, they are done by college students. One of the more impressive ones is Event Horizon. It's like a space age kind of a game. There's Geometry Dash. There's a version of Geometry Dash if anyone played that. There are lots of different clones of popular video games that you can find on Scratch, which proves to you that Scratch is a very sophisticated tool. It allows you to prototype programs very quickly. When I've had ideas to prototype certain programming with a book that I wrote, an online book that I wrote, I was able to put it together in Scratch within like a half hour, whereas coding it out in Python or Java or some other programming language might take quite a bit longer. Now, you'll also notice that this zebra, once we turn it into a horse, has two different costumes. The two different costumes allow you to give the impression that the horse is moving, which is something that we want to do for our simulation. We're going to get the simulation started today, and I'm hoping we'll get to finish the simulation later. Let me just match the color. There we go. Just to get rid of stripes. There's a little bit of shading. And now I have to get rid of the stripes on the back leg. I'll probably have to add some hair to the tail also, because horses do have more hair in their tails than zebras do. But let me get rid of the rest of these stripes. That's with the paint bucket function. It will take a little bit of practice if you're not familiar with this. However, if you are familiar, you can probably just fly through this part. Let me use the paintbrush. Let me set the color for the paintbrush. And now I will use that paintbrush to start painting in a tail. That's kind of thick. Let's get something a little bit thinner. Try 5, 4. We'll see. Well, at least to start, that's not too bad. So I'll have the tail a lot hairier than the zebra tail, because these are horses that live up in that Russian park. Here we go, filling in all of the hair. And what I want to do today is put the herbivores in a park, in a Pleistocene park, as we saw Pleistocene being the time of the ice ages, and how in Siberia they're trying to recreate the ice age in order to keep the permafrost frozen. It's an incredibly ambitious and incredibly smart idea, but we don't have any zebras living in that park, so I'm going to make sure that both of the costumes that we have for the zebra are now a horse. The sprite is still called zebra. We could change that. I'll show you how to change names a little bit later on, because zebras are generally tropical animals, and horses can survive in much colder, harsher environments. These are Yakutian horses that they have at the Pleistocene Park. Yakutia is a region of Siberia, and these horses are very well adapted to living in extremely cold weather. Now, let me make sure I get all of the stripes taken care of. You may need to stop this video. You may need to fast forward, rewind, make sure you understand things. That's why I'm putting this in a video form, so that it might be easier to understand overall. This will be the last grade for Introduction to Engineering. Some of you will be moving on to exercise science, probably a lot of you will be. So this is the last project to get done in the engineering class, although our first project for exercise science will also involve some computer coding and putting together some hardware. But I just wanted to give a real quick experience with programming a simulation, because in engineering, quite a few times you have to make a design for whatever it happens to be. You have to make a model for whatever engineering challenge. You would have to model it on a computer before you would actually create it. We might want to model an ecosystem in Siberia and see what the dynamics would be before we actually release the large animals. Although large animals are much easier to remove from an ecosystem than small animals, as Sergei Zimov has said himself, that we don't if we ever did have a problem with these animals causing damage to the Siberian Arctic regions, we could just remove the horses and the bison and the muskox and the other creatures fairly easily. All right, so notice how my horse now, if I switch between one and the other, it at least gives something of an impression of movement, which is something that I'm going to want for the simulation. Looks good. Maybe I just need to fix on the other. I don't want the stripes again, clearly. I don't want to reverse the stripes, as that's trying to say. Let me see if I can actually fix the mane. I messed it up, and the ear line, I messed them up a little bit on the other horse. Let me see here. So I can fill in that spot. And it looks like maybe I can fix it on the other costume as well. Let me just double check here. I'll get the line color that I want. And everything there looks pretty good. Now I can fix that mane on my other horse and fill in that line for the ear. There we go. My horse is complete. And the horse is in a white background. That white background represents the snow of Siberia in winter. Thankfully, we do not need to change that background. Now I'm going to start putting together some code here. You see the green flag up in where the horse's box is? That green flag. So when I press the green flag, I'm going to make some things start happening. First thing I want to do is switch the costume and wait a second, and then maybe I'll want to make my horse. When it moves, I'll have it switch costumes every 0.5 seconds to give that impression of movement. It's a little bit of an animation. I'll just make sure I'm in the look section with the switching costume. Then I go to controls, where I control how often that happens. And I also would want to put this in a forever loop. It's a very important concept in computer science. And now that horse will continually be switching. Doesn't quite look like it's moving, but it looks like it's moving, but it doesn't quite look like it's walking. But otherwise, we're going to have to move the legs around completely to give a better impression of it walking. Make it about size down to about 20, because that's probably a fairly good start for where we want to begin. And now I want my horse to start moving around the screen. Remember, these horses are constantly moving, constantly looking for food in the wintertime. So now I'm having my horse randomly go from one place to another in search of food. While it's walking on the snow, you might remember that it's packing down the snow. And while it's looking for something to eat, it's clearing off the snow, which allows the really cold Arctic weather to get down into the soil and help keep that permafrost very cold. From there, I want to find the pen, which would... why don't I just show you how you can do a sound if you want to. There's a horse gallop. Now, the way I'm recording this, you can't actually hear the horse gallop. You would be able to as you're setting up your own. You could record your own sound. The horse gallop might be a little annoying after a while, as you will find out if you end up putting that in on your own. But you can use that horse gallop if you want. I kind of found it annoying pretty quickly. The other thing you would want to do is go to the pen. The pen is going to draw a line behind this horse, kind of like the horse is scraping through the snow and clearing off the snow everywhere that it moves, exposing the soil underneath so that everything stays very cold and frozen. Now, the pen has been moved from the spot where I used to use it, so you have to go to that blue spot on the bottom and find the pen in order to add that set of blocks. All right. Now, I want to put the pen down. We don't want it red. We want it a brownish color for the soil. So I'll have to play around a little bit with what that color might be. Don't want it green. It's getting close. There's a pretty nice brown color there. All right, just fiddling around, playing with the controls. You can do that. If I put the pen down, you can see now it's making a line behind it everywhere that the horse goes. That line is way too small. This is the idea of the horse clearing off the snow. Have to play with the size a little bit. There, that's 10. That looks pretty good. Yes. So now there's the path that the horse carves in the snow everywhere that it walks. I don't want to keep that snow completely cleared. So over time, maybe we have the soil get covered up again. I could do that with a control. Let's see. All right, I'll do the time for maybe I'll make it like a second, and then I would have the pen erase or get erased, which would be the top button here. Right, so it'll erase it after a second. So every time the horse moves, it clears some snow, and then it gets snowed back down, or the snow blows back over the soil. Still, in the real world, it's cleared enough, the snow is cleared for long enough that the ground can freeze colder. You may remember the permafrost in this particular location is 2 degrees colder than permafrost in other locations, thanks to the work of those plant eaters. Now, if we want to add another plant eater, we go back to sprites. We use the horse already. Let me see. Animals. Definitely not any crabs in Siberia. We have the llama, which is kind of like a camel. And some of them are adapted to living in colder climates up in the Andes Mountains. So we can make a llama. And the nice thing about, well, once I get the size adjusted, maybe I'll make that 15. Llamas aren't super huge animals. They are a kind of camel. And we did make a humped camel in the origami unit. So I'll just make this, we'll pretend it's a camel, make it a little bit smaller. Now, the nice thing about Scratch, again, I can just copy this code and drag it. They used to have a stamp where you could copy it. Maybe if I just try to drag it straight over to the llama, it will allow me to do that. Yes, it did. Wait, I think. Yes, okay, I have the code. So now when I hit the green flag, both these creatures, yes, are clearing soil or clearing the snow off of the soil. That's another very important step here. Now, the other costume of the llama is where it is laying down. That doesn't really look like it's walking or moving. We could animate it. We could make another costume that would make the llama actually looking more like it's walking. But I'm going to move on from there, and we want to add, in addition to our horse and our camel, you remember the problem in this region is that there are trees growing in the tundra, and the trees absorb heat in the Arctic. They keep the Arctic warmer than if you have a grassland. I think that's about a good size for a tree, 30 pixels. And we'll play around a little bit with the code because the trees could keep growing. We'll have more than one tree growing. So when the green flag is clicked, We'll wait a second to get started, and we will hide it at the very beginning, no trees, and then we'll show it after a second. Once we hit that green flag, you'll see a tree. The other thing is we want to have more than one tree growing. So we'll put the trees in random positions because the trees wouldn't move, but a new tree could sprout in a different location. I'll put this next part in a forever loop. We'll wait, let's say, for trees to grow, they take a little bit longer, like every 10 seconds maybe. We'll have a new tree growing. And I would do that by creating a clone of myself. Now, I'm kind of experimenting here in addition to creating this. We'll have to see how this works. Will it create a clone every 10 seconds in a different location? Let's see. A tree went somewhere else. I mean, that's not a perfect way of doing it. Maybe we'll have to adjust that. But does it create a clone of itself? The problem is I said, yes, there we go. So we have trees sprouting, growing. Every 10 seconds, a new tree will grow. Now we need to give that clone instructions on what the clone's going to do. When I start as a clone, now we're going to give controls to other trees. The point of the trees, we want the trees to get knocked over. We want the trees to get destroyed. I did see there was an elephant here. And we can turn that elephant just like we've seen in the videos. We can genetically engineer this elephant into a woolly mammoth. Now, if I look at the costumes for the woolly mammoth, or the elephant to start, it has that kind of looking like a pushing something with its trunk, and then the walking elephant, or the walking mammoth. We won't make it, we don't have to draw all the fur on it, I guess. We'll just change the color from the gray of a typical elephant to the brown fur that you would see on a woolly mammoth. Just in the interest of time, we are already moving past 22 minutes. So let's get the right color, a brownish color for the mammoth. And I'll want to make sure that both costumes are the same color. I go to my fill bucket, I start filling in parts. Would be better if it looked shaggy, but we're not working for perfection here. If you want to draw some fur on the mammoth, certainly you can feel free to. I'll make the inside of the ear a darker color because it would probably have more fur inside of its ear to keep well insulated. And I guess we can make the eyebrows or whatever those things are a little bit darker color, just to give it a little personality. Now I'm going to change, this was the darker color inside the ears and on the eyebrows. The rest of the elephant, I want to use my eyedropper tool, make sure it's matching color. I don't want my mammoth changing colors between one format and the other. All right, so the elephant will push down trees when it takes this costume, or the mammoth will push down trees when it takes on this costume, and it will just kind of have that other form when it's moving around. It would be better to have it actually walking, but again, we don't have a lot of time to set up everything to perfection here. Now, the code for the mammoth. Every time the mammoth touches a tree, we want it to push. Otherwise, we want to have it as its kind of other form, the walking form. We'll have the elephant go random positions. And if it's touching the tree, it will react. So we're connecting it to what happens when it touches the tree. It will change its costume into that pushing costume. Right now, I haven't put anything about it changing from one costume to another. So elephant B is where it's pushing, and elephant A is where it is the other form. If I hit, well, okay, I want this to keep going, so I want to put this in a forever loop, which would be down here. Okay. Get the whole thing in a forever loop. Except for when it changes costume. Oh, wait, whoops. Okay, so right now it's going to random positions. It's not gliding to random positions. So it's just randomly appearing in different locations. That's actually not the code that I wanted to include. Again, here's the nice thing about Scratch. You don't have to worry about typing things properly, and you can just swap one block for another. Mammoths move slower than the other animals because they're elephants, basically. So we'll just have that go 5 seconds to every location. And it touched the tree. It touched the tree, and it stayed, because the way I had it programmed first, it stayed in that pushing shape. But I don't want it to keep pushing now everywhere it moves. So I'm going to have it switch back to elephant A after a second. So whenever it touches a tree, it should make, it should make that push. Sometimes these sprites aren't the most sensitive, which means that it could be an issue that it's not, when it didn't make that push, it didn't make that push costume. Well, here, I'll set up that it also clears and packs the snow. That's something else that the elephant does. I want to set the pen color to brown. Same as the other creatures. Same soil it's clearing. And I need to put the pen down. And it should now leave. I need to set. Okay, so, It's not. You did just see it touch the tree, and it went to that pushing costume. Now I have to set the pen. It's actually, that's not the right one. I have to do the pen size. Set pen size. And again, this is the nice thing. You can switch things and swap things very quickly. And this could be written as Python code. This could be written as Java code. But if you're typing things wrong in Python or Java, the computer won't be able to read it. Here you don't have to worry so much about typing, which is the advantage. Okay, now that's a little bit too big for the elephant's path. 40, I guess that's pretty good for the area that it clears off and gets covered up by snow again. Now when it touches a tree, it should make that push if it's done properly. And now I want to change the tree. So when the tree touches the elephant, it's going to get killed. We want the elephant. Trees are great in the tropical regions. Trees are great in the temperate regions, like where we live. Trees are great. Trees are not great in the Arctic because, as we know, they capture warmth and channel it into the soil and help to melt the permafrost. So the reason why we would want to bring back the woolly mammoth is because they can destroy trees. They knock trees over. This is what elephants in general do. Elephants keep grasslands as grasslands because they tend to knock down or tear down trees wherever they happen to live. This is true for African elephants in the savannas of Africa. It's true of Asian elephants in the forests of Asia. They will tear down trees, especially African elephants. And woolly mammoths were thought to do the same thing. Okay, so I just made an extra costume for my tree. I went down to the scratch. I picked another costume for this tree. Now, this is a vector design, so it actually is a lot easier to work with. I can turn the trunk. I'll have to turn it a little more. But I want that trunk to be knocked down. Let's see if I can just make it nice and horizontal. There we go. And the tree is going to be dead when it gets knocked over. You can see already on my screen some of these trees are being changed already to that knocked over form. I'll need to get rid of my... Whoop, I deleted the whole thing. I didn't want to do that. Maybe if I click here, if I hit the delete button, it'll chop out. Just hit the delete button on my keyboard. It's going to get rid of all of these leaves. So this looks fine. Now I'll need to paint some dead branches. Make sure I get the right color. I want somewhere like that. And then I'll draw the branches. It's a little too thin. Like maybe a 10. Yeah. Again, we're not striving for a major work of art here. If you want to take more time with this, you're certainly more than welcome to. But if yours looks as good as mine, we're in perfect shape to get a good grade on the simulation. If it doesn't, if it's worse in terms of artistic quality, that's fine. But you can see, you can see that the trees are looking pretty good there. So I'm not judging on artistic quality. I want to make sure that this program works. So I'm going to have it always start at tree 1. And if it touches the elephant, it will go to... I don't like the fact that they both have the same name. So let me go check in costumes. And I can change the name. So that one is tree 1 right now, but I can just change that to like fallen. Something that I understand. It's important in computer code to put things that you understand so that both you and someone else looking through the code will know what that means. So fallen obviously is a tree that's been knocked down. When the clone... Actually, the tree will die. The tree will get knocked over, the tree will die, and the tree will decompose. So I'll hide the tree after it falls down. Okay. So this should be most of what I need. I'd like to make a copy of this for the clone as well, at least what's in the forever loop. I should be able to do that with Command C. Maybe I can try Command C. Because if I pull it out... All right. I want all of that stuff on the inside. I'll have it when touching elephant. I want the clones to fall down as well. The cloned trees to fall down as well. I can just recreate what I have there, I guess. And wait 1 second, and then it'll hide. There should be a way to copy and paste. Maybe I'll try that again. But it's still fairly simple just to do it this way. So now whenever the elephant touches a tree, it knocks it over. And so the elephant should touch a tree, should push on it, should knock it over. Don't really need the clone going to a random position. Okay, woo. So there the elephant touched. Again, the sensitivity is not great. I did just see that the mammoth, I'm sorry, I keep saying the elephant. The mammoth touched the tree, but didn't actually cause it to change costume and get knocked over. Let's see. Oh, there we go. One did there. And again, a lot of this is just putting it together to see what works. The clone should go to a random position. I don't want the tree to keep making a clone of itself in the same place, because that's what it'll do. That's actually what looked like happened previously. So that when I make a clone, I want it to appear in a... Okay, there we go. Now it's appearing in a different spot. It's going to a random location. And I've sped up the number of times the trees grow just so that I can test this a little more quickly. So now I have my tree getting cloned spawned at every 2 seconds. Oh, so it pushed that tree, but it didn't knock it over. The tree and the elephant aren't quite sensing. Oh, okay, so there a clone appeared where the mammoth was and the tree got knocked over. Let's see here. Did not sense them. If that one doesn't get knocked over. Wow. So why isn't our elephant should be knocking over these trees? Why is it not? Oh, because we have to put this in a forever loop. That's what it is. Now, every time a tree touches the elephant or a clone touches the elephant, I might have to reset the code. Okay. So now anytime I have a clone being made in a forever loop, every time any tree, there we go. Okay, good. Anytime any tree touches an elephant or a mammoth, it gets knocked over and dies. All right, good. That's what we want. And if we can get to this point by the end of today, great.